Hi, everyone. My name is Mark Cook. I'm the founder and CEO of a studio called Shiny Shoe. In May 2020, we released a game called Monster Train. It's a deck-building roguelite card game where you play as the monsters of hell in a struggle against a splinter faction of warriors from heaven. To put it simply, it's a card game that's meant to be replayed many times. Its replayability comes from a wide variety of potential outcomes and a high density of interesting decisions. It's a game with a ludicrous title, Monster Train, which I see as a triple entendre. 1. Your forces travel through hell on a huge train. 2. The train is filled with monsters. And 3. You are training those monsters to make them stronger during play. One of Monster Train's core twists is its blend of cards and a sort of tower defense. The forces of heaven attack your train and attempt to board to destroy your pyre, a magical crystal at the top of your train that is its power source. It's up to you to strategically deploy your forces and cast spells to stop them before they do so. I suppose it's not surprising Monster Train has a silly name coming from a studio named Shiny Shoe. Ridiculous names are in my blood. To give some context on the studio, Shiny Shoe was founded in 2011. We'll be having our 10-year anniversary this year. We've got 14 full-time people on our team, and Monster Train is our best-known original game by far. And yes, I named the studio after a pair of shoes that I have. And you better believe that I still have them 10 years later, and I'm wearing them right now. Unfortunately, GDC is not in person this year, or I'd gladly show you. This postmortem is about process and pipelines. I believe the processes we applied when building Monster Train were a major factor to the ultimate success of the game. Our processes led to the development of various pipelines and tools that paid off dividends across the course of development. In this talk, I'll be sharing our key processes with concrete takeaways. I'll start with how we approach prototyping, go through our production, and into post-launch support. Overall, this postmortem is going to focus more on what went right, more so than what went wrong. That's not to say that everything was perfect in the development of this game, and we certainly had our missteps. But I chose to focus on what went right in this talk because I think we have more actionable takeaways to share. We started development by making multiple games in a team-wide series of prototypes across multiple weeks. Sort of like a game jam and conceptually similar to Double Fine's Amnesia Fortnight, if you're familiar with that. Our core goal was to find a promising concept in a genre that the team likes. We split the team up into multiple small groups of 2 to 4 people to flesh out ideas into playable form. Teams were given the space to explore varied concepts and pivot them as needed during the time allotted. One of the prototypes is what ultimately became Monster Train. Here's what the prototype looked like around the time that we decided to move forward with the concept. If you're familiar with Monster Train at all, you'll see that although a lot of the details are different, there are a number of recognizable things in this screenshot, like the cards, the multi-floor tower, and how the units are positioned in a room. Compare the prototype to what the game looks like now, and you can see how the same core concepts are still represented. Other than the thematic and visual differences, one major gameplay difference we explored while prototyping was advancing the game state in real time. In this initial prototype, units would battle it out automatically and climb floors automatically, regardless of player input. There was no concept of a discrete turn. The player gained energy to cast cards based on a timer. We ultimately decided that this approach didn't feel right for the type of game we wanted to build because real-time forced us to downplay the deep, mathy decisions that make these types of card games fun. So ultimately, we switched to the more traditional turn-based model. The key point that I want to make is that giving our prototype teams the time and space to try a variety of ideas, we were able to land on something we felt had promise. To add a dash of reality on the business side, for us as an established studio in San Francisco, it took years for us to build up the cash reserves via contracting and royalties on other titles to be able to do an all-team prototype process like this. I'm not going to spend any more time talking about how we prototyped because there are many great GDC talks about the topic from past years that you can reference, multiple of which are available on YouTube. Speaking of business reality, one of the things we knew from the outset was that we were not going to be able to afford to develop the game with our own cash reserves at the scale and quality we aspired to target. So, of course, it was time to pitch. We began working on a more fleshed out first playable that encompassed the core gameplay loop, along with some of the metagame structure. In parallel, we defined the target scope, the number of team members we'd need to execute on that scope, a proposed milestone plan with deliverables and dates, and a development budget. I set up a simple pitch pipeline to track all the opportunities that helped us stay organized during the pitch process. My tracking for our pitch pipeline looked like this, a simple spreadsheet. For each potential publisher or other funding source, I tracked who they were and what phase of the process we were in. For example, initial contact, pitch sent, actively negotiating, whether or not they passed, and so on. For each potential target, I also tracked a heat rating to indicate how interested they seemed to help direct my attention. My ratings were cold, contacted but not much going on, warm, contacted and seems interested, hot, seems very interested and is moving actively through the phases, and dead when there is no opportunity. Other than that, I added a simple last contact date field and notes about the current status to help me remember what is going on. In the end, we pitched 36 different potential funding partners. Unless you have an existing well-known track record of success, expect to hear no a lot. We certainly did. We ultimately closed a deal with Good Shepherd Entertainment, who was a great partner for us. It took almost exactly 3 months from the start of pitching to closing a deal, which from my experience is typical, so plan accordingly. You don't want to go bankrupt right in the middle of negotiating details. After closing the deal, and as we began full production, something we wanted to establish early was a culture of feedback within the team, because we think it leads to the best possible titles when the team feels engaged and heard. When defining culture, it's important to clearly state the outcome and the behaviors associated with creating that outcome. It is also critical to define the process around those things as well. For feedback, we did a few things. First, we repeatedly asked the whole team to provide feedback. This sounds simple, and it is, but it's always useful to repeatedly remind what we are looking for. We also scheduled recurring internal playtests. For us, a cadence of once or twice a week worked well, depending on the phase of development. We encouraged everyone to provide their thoughts during and after these playtests so that we could improve the game. Finally, taking inspiration from Unknown Worlds' games Natural Selection 2 and Subnautica, we added an in-game feedback tool. This tool had the highest return on investment of anything I've seen in my career when comparing the amount of time it took to develop to the amount of benefit we got from it. Shout out to Brian Cronin on our team who suggested that we add the feature. The goal of the tool was to essentially provide an immediate way for someone playing the game to share their thoughts with the rest of the team. It was often used for reporting bugs, suggesting polish improvements, commenting on game balance, and giving praise. In pre-release versions of the game, we had a persistent on-screen call to action, telling the player what hotkey to use to pop up the feedback UI. I think this decision was important as it greatly increased the discoverability of the feature once we started to do wider beta tests. When the user submits their feedback, in addition to the text they typed in, our system captures a screenshot, their log file, and their current save game. These additional pieces of information helped understand feedback more quickly and perform post-mortem debugging. Here's what it looked like. In the lower left corner, you can see a call to action, beta. Press F8 to give feedback. When the simple UI appears, the user can type in their thoughts in a large input field and then submit them. It's all very simple on the client side. We wrote a custom backend to receive the data. We then post it directly into Slack using the Slack API. This is a screenshot of how the feedback in the prior video appears. It's got my Steam username, what build I'm playing on, the time, and of course my comment, along with other information. This is posted into a public Slack channel that the entire team is a part of. We made use of threaded discussions on feedback entries to discuss feedback in more detail when needed. As an aside, the emoji faces surrounding new feedback are the glaring eyes of our creative director, Andrew Krausnick. We randomized the emojis between a bunch of our internal custom emojis to add a dash of silliness. The first 3 messages in each thread were also posted by our Slack bot and include the log file, save game, and screenshot for quick reference and download. We made it easy to copy the save games into debug builds to rapidly enter the same state the player was in if we were trying to reproduce a bug. If you take nothing else away from the talk, please take this suggestion. Copy this system into your game. The amount of beneficial discussions, bug reports, and so on that we got from this feedback system was enormous and made a huge impact on the final quality of the game. Now, let's switch gears and talk about production management and scheduling. At this point, we had signed a contract with specific milestone dates. We were determined to successfully deliver on our promises on each milestone without needing to delay any of them. We were also determined to try to make the best game we could. Meeting deadlines and making a great game can sometimes be conflicting goals. To try to mitigate the likelihood of failing on either meeting our deadlines or failing to make a good game, we developed a straightforward production management approach that worked well for us. Our goal was to prioritize what mattered most when it came to delivering value to players, while simultaneously bringing visibility to potential blockages where 2 or more tasks depended on each other. As we proceeded through production, the laser focus on working on what felt most important to the team meant we reorganized our roadmap many times during development. On an individual person's roadmap of tasks, we would often move items we had scheduled to happen later to happen earlier instead, trading with something else. This flexibility allowed us to backburner or even cut features that sounded good on paper, but no longer seemed as important as other things due to changing conditions. However, I previously mentioned that we had milestones with our publisher. Milestones come with contractual deliverables. Sometimes you might not be able to make a feature cut if you signed a contract that said you promised to deliver that specific feature. I have 2 short pieces of advice for this. 1, where possible, try to write your milestones to give yourself flexibility. And 2, if you're working with a partner, find someone who is reasonable and trusts you to make good decisions. We ultimately did end up cutting something that was specifically listed in our contract, but our publisher accepted that cut unconditionally because they trusted our judgment in wanting to apply the budget to another feature that we believed had more value for players. To make sure that we kept our contractual deliverables in mind, we plotted them out in the master schedule, clearly indicating on what date they landed on. We reviewed how we were tracking towards our milestones on a weekly basis and adjusted the order of our tasks as needed. Ultimately, we organized our work into weekly buckets, or sprints as they are sometimes called. We used a spreadsheet to track the high-level long-term roadmap and separately used Jira to track individual tasks and bugs at a more granular level week by week. This is what our high-level production roadmap spreadsheet looked like. Columns broke the production down week by week. Rows were individual core team members. For each person, we roughly stated what we expected them to be working on each week based on our overall schedule estimates that we made when we first signed the contract. Vacations were plotted into this sheet so we could plan for and work around them. There's nothing complicated in here at all. In fact, I'd argue that the simplicity is a benefit. The main point is that we looked at this spreadsheet frequently and adjusted as needed all throughout development. The fact that this approach is simple made it easy to move things around, which helped to quickly model different scenarios. Individual contributors on the team mostly paid attention to Jira, where we had more detailed tasks and bugs written up. But I'd also solicit feedback on this roadmap from everyone periodically to see if the estimates still lined up with reality. I'm sure this approach falls apart if your team size grows to a certain size, but for Monster Train, it worked. And one thing to note is that the majority of the art schedule was not included in this roadmap. We outsourced a significant amount of the art production and tracked those pipelines in a different way. So let's talk about our art process and pipeline. Our primary goal was to build a lot of high-quality assets without a large internal art team. As a small company, we can't afford to have a lot of artists on staff because of the typical art production demands that rise and fall depending on the phase of production. We needed a lot of artists before alpha, but after that, our needs on the art side were minimal. This is a typical situation and a classic reason to use outsourcing. We didn't want to hire people only to have to lay them off 9 months later. I'm not an expert in managing art teams, but luckily my co-founder Eugen Kim is. The advice here all comes from him. So let's go over how we built an efficient production outsourcing pipeline for Monster Train. Once we decided upon our overall art direction in pre-production, we defined a clear style guide, otherwise known as the project's Art Bible. Our Art Bible included summaries of things like gameplay, story, tone, character factions, visual goals, and visual do's and don'ts. It also had technical requirements for asset production, camera, lighting, poses, and Photoshop file organization. By having all of these components clearly defined, we were able to onboard new artists rapidly and ensure that they were able to deliver assets that were easy to integrate. For each type of art asset, we defined a clear pipeline of steps for how we'd go from initial design to final in-game asset. We used a Kanban board in Jira per asset to track the status, which gave interested parties full visibility into the status of each asset. We included review gates at different parts of the Kanban pipeline so that there were chances for feedback at different points. It's always cheapest to iterate on something when there is the least amount of work put into it, so it's important to front-load reviews when it is cheaper to iterate. The last thing you want to do is only have an asset review after the final version is delivered and have to do substantial rework at high cost. One of our asset types was a spell card. Let's use that as an illustrative example. These are cards in Monster Train that don't have an associated in-world character. Our Kanban pipeline for spell cards looked like this. We started with a paper design where we described what the card represented, how it fit into the overall lore of the universe, and a written description of some ideas for how it should look. These were written by game designers on our team. We'd then have a review meeting with the design team and our art director to give feedback and talk through any potential issues on the art side. Sometimes these designs were approved with no changes, and other times they required a round or two of iteration. But remember, at this point, we're talking about a page or less of text in a document, so turning around updates was very quick. Next, we'd go to a sketch stage, usually black and white, where a few different approaches were considered by the artist. The artist would deliver these sketches to our team, and we'd provide feedback. Sometimes this resulted in another round of sketches, and other times we moved forward immediately if one of the ideas was working. Then, the artist would do the primary painting of the spell using the sketch we chose as a guide. Once they had a strong first pass, they'd send it back for feedback again. At this point, though, because we'd already reviewed the design and the sketches, there weren't really many surprises, so the amount of feedback at this point tended to be smaller. Finally, the artist would finish the painting and polish it up. At that point, it would go through the final two parts of the pipeline, integrating it into the engine from its Photoshop file and doing some shader-based animation to make parts of the card move. Finally, some spell cards required custom visual effects, and our effects artist was at the far end of the pipeline. Here's the final result for the card Ancient Synergy. Overall, this process and pipeline allowed us to scale to 23 artists at peak, delivering on over 200 cards and 100 character units. Now that we've covered art, let's talk about game design. Our process for game design iteration was focused around embracing emergent fun. Like any game design team, we had a lot of ideas that we thought sounded good on paper and that we wanted to put into the game. However, as we all know, when you add features into the game, some work out better than others. Ultimately, the best way to summarize what we did was that we doubled down on what was working and dropped the things that were not working. Anytime we agreed upon a major design pivot, we immediately updated the master schedule that we talked about earlier so that the changes were incorporated into our long-term planning. Because the master schedule was so simple, it was usually easy to move things around to accommodate these types of changes. Now let's look at a concrete example of embracing emergent fun. One feature we put into Monster Train is the ability to copy cards in your deck. This is powerful in our game because you can upgrade your cards to increase their power. And when you copy a card, its upgrades are also copied. In this example, I have a Cuddle Hex card with the Immortal Stone upgrade granting it Endless. The Endless trait means that when the unit dies in battle, the card comes back into my hand. We found players really like copying cards with their upgrades because making smart decisions about what to copy makes players feel both powerful and smart. It's fun. So how could we further embrace emergent fun? What if you could copy your card 5 times? Maybe you'd feel 5 times as smart. The funny thing about copying a card 5 times is it's really tempting, but it can often backfire. Having too much of a good thing in a deck building game can choke your deck with bad hands. But it can also work sometimes, and it's a fun moment. An example of where we dropped a feature that wasn't working was a system we had in the game called branding. It was a sort of Pokemon-style card evolution. Players could take a unit card, like the Horned Warrior, and apply a branding upgrade to them to get the Branded Warrior. The reason we ultimately felt like this wasn't working well was that it was constraining the mechanical breadth of our unit cards. For each unit that supported branding, both the pre- and post-evolution card had to have tightly related mechanics for the upgrade to make sense to the player. If the mechanics of the card totally changed, it wouldn't make sense. On the art production side, we also had to build 2 versions of each branded unit, which meant that for each mechanical purpose a branded unit was filling, we had to build double the amount of art assets as normal, tying up our art budget. Fairly late in production, we decided to throw out the branding system completely and redesign all the branded units to be independent units. This was more fun for our players because it meant that we had more mechanically varied unit cards in each of our monster clans, because we no longer had to thematically connect branded units together. This meant more potential unit cards could show up during drafts, increasing the number of potential outcomes in runs. We definitely think this was the right move for the game design, but it did have one drawback. We had already put a bunch of units through the art pipeline that were clearly designed to be stronger versions of other units, just like the Horned Warrior and Branded Warrior you see here. We ended up shipping them this way due to budget constraints, even though in the end they didn't have tight mechanical connections anymore. That wasn't ideal, but we think it turned out okay. Let's shift gears and talk about tech. Our primary process goals were to focus on iteration speed, knowledge sharing amongst the engineering team, and maintaining a stable build. We used a few concrete processes to help us reach those outcomes. 1, we used a pull request workflow via GitHub to spread knowledge of different systems across the team. We weren't dogmatic about requiring pull requests for every commit, and for flexibility allowed small commits to go straight into the main branch. But we wanted to have all larger changes get a review by at least one person. This helped our engineers both catch issues before they went into the main branch and spread out knowledge about how the game works to all the engineers. We also set up automated error collection and continuous builds. Let's look at both of those in more detail. First, as a way to improve build stability, we implemented a custom method for automatically collecting errors. In our case, that meant uncaught exceptions. This screenshot shows a report of recent exceptions back in January 2020. On any uncaught exception, we would upload the stack trace, the player's log file, and the player's save game to an error collection service that we run. The error collection service could dedupe errors based on their stack, and then sort errors based on their frequency to help guide our focus. A report was posted into a Slack channel every 24 hours with the top errors of the day. We made it a priority to fix these all throughout development. Having the save games and log files made bugs far easier to reproduce. To ensure everyone on the team always had access to the latest version of the game, we built the game on every single commit via a Jenkins build farm. We also uploaded those builds to Steam on every single commit. This screenshot has an example of us uploading a new version of Monster Train 9 times in less than 6 hours via our handy butler Jenkins. At peak, we uploaded around 50 builds a day. Shout out to Valve for enabling this workflow. Not only did running builds all the time catch build errors, which became very rare since issues were fixed immediately, it also meant that anyone on the team and our external partners always had a version of the game that was on the bleeding edge that they could play. Eventually, as we added more platforms like Xbox, we started building all of those too. We leveraged cloud resources to bring up and tear down build machines as needed. Now let's talk about pre-release testing. We benefited greatly from player feedback ahead of release, and I highly recommend trying to gather as much feedback as possible. Our primary goal during these tests was to fix all recurring player complaints before launch. As anyone who has done player testing on a game before knows, as soon as you start showing your game to a handful of people, you'll start to see trends in feedback. Multiple people will report the same bug, exhibit similar confusion over how a feature works, think some element of the game balance is off, and so on. Even with a small sample size, these trends are very meaningful and powerful. We wanted to fix every single recurring problem pre-release that our testers mentioned. We did this by running both a private and public beta ahead of release. Our private beta was NDA'd and organized via private channels in Discord. We patched the game frequently, often as frequently as every single day, and posted patch notes for all changes. This kept our testers engaged as they could see changes were being made based on their feedback and watch as content and polish rolled in. Our core group of private beta testers continued to help us test the game post-release and is still helping us today. So I want to give them a quick shout out to all the folks in our private beta. Thank you. Our public beta was framed as a demo, but it was essentially a pre-release beta test. We planned to keep it up for only 2 or 3 weeks, but ended up extending it by a week or 2. We launched it on Steam as a demo under our main product ID and did some marketing at that time to raise awareness that it existed. During this time, our in-game feedback feature paid off massively. We got an enormous amount of feedback from our players. That Slack channel I mentioned earlier was under a constant flood of feedback. It was time-consuming to sift through all that, but immensely valuable. Every few days, I went through all the feedback, organized it, sorted it by frequency of reports, and assigned the tasks out to the team. I honestly think we fixed every commonly recurring complaint before the game shipped. This meant we shipped with a much higher polish level than we would have otherwise. We ran professional QA in parallel, testing both functionality as well as localization. That was valuable, but we got less subjective feedback from those channels. I mentioned Discord, so let's talk about community. Our goal with community management was to stay directly connected to our players to make sure we were serving them well. We set up an official Monster Train Discord server to be the primary point of contact for our community and put a button right on the main menu of the game that links straight into our Discord server. By having a direct link to our most engaged players, we had a channel to hear about what bugs or balance issues they were most concerned about, and we had a way to solicit direct ad hoc feedback. To ensure the community had a welcoming environment, we set ground rules of basic politeness and positivity. From our engaged community, we looked for moderators who might be interested in helping us maintain the rules. Thankfully, several people volunteered. They have been instrumental in helping keep the Discord server peaceful, so thank you to all our mods. We empowered both our dev team and our mods to engage directly with the community and trusted that people would be able to handle themselves well within the general public. Not everyone wanted to engage, and that's totally fine. But I believe we benefited from having several folks on the dev team interacting with our players on Discord in a variety of capacities. Outside of Discord, for nearly a year, we did weekly developer streams on Twitch and on Steam. These streams exhibited parts of the game, talked about upcoming changes, and fielded questions from the community live. These streams mostly served our most engaged players, but were a useful additional way to help stay directly connected. Finally, we built a custom Discord bot to help facilitate gameplay conversations. Using the bot, players could summon up information about cards and other items in the game, as well as check various leaderboards. In this video, you can see a sample of me requesting the details of the Eel Gorgon unit. Part of our build process captures all images of all the cards and other items so that they are always up to date, which makes it easy to keep the bot in sync with our game data. So, how did it turn out in the end? I'm very pleased to say quite well. Monster Train was the #1 global top seller for a time on Steam near release. It was named PC Gamer's Best Card Game of 2020 and was nominated for a DICE Award for Best Strategy Game. I'm most proud of our Steam user rating, overwhelmingly positive, which is the highest possible rating that requires 95% or more of your user ratings to be positive. I had set that as a goal for our team to target early on, thinking it sounded ambitious and was likely out of reach, and I'm really proud of what our team was able to accomplish. I believe that the processes I outlined today were a major contributing factor to the success of the game. In summary, the key processes and pipelines that led to our success were an organized prototype process and an efficient pitch pipeline, establishing a culture of feedback and building tools around that allowed us to efficiently gather a wide variety of inputs that helped us improve the game. Maintaining a long-term forward-looking schedule allowed us to flexibly pivot our focus while keeping an eye on our milestones. Creating a well-defined and efficient art pipeline allowed us to build a lot of content while keeping our core team lean. Our tech processes and tools helped us iterate quickly while keeping the build stable. We gathered an enormous amount of feedback from players in both private and public betas that helped us resolve all common player complaints ahead of launch. And finally, we used our Discord as our community meeting place and worked to maintain an ongoing direct path to talking to our players both before and after launch. Thank you for your time.